Hello, good morning once again. This is Mrs. Teresita B. Moreno welcoming you all to Physical Science um, tutorial lessons or refresher lessons on chemical reactions. Now, when we talk about chemical reactions, as we mentioned before, there are important components that we can say that there is chemical reactions. One is substance or particles must be in continuous or continuously collide with each other with correct orientation. And of course, there should be enough activation energy in order for the substance or the two chemicals or two elements will react with one another and form into products. Okay. Here are some symbols in chemical reactions. When you see a positive sign written between the symbols or formulas of the reactants and products. Then if you see a symbol, arrow symbol, it separates reactants from products. S for solid, L for liquid, either the reactant or the product is in liquid form. Then G for gaseous reactants or product, and AQ for aqueous solution. When I say aqueous solution, basically the solvent is water. So the solute is being dissolved in water. So when you see an arrow with a triangle on top, it is an indicator that heat is being applied. And if you see an arrow with a catalyst written on top, so that means, or it means there is catalyst present. And if you see an opposite arrow, this is reversible reaction. When we talk about reversible, it means you can change it or you can reverse it into its original formation. For example, the solid ice placed inside uh, the refrigerator, so it is in solid form. When you remove the ice outside the refrigerator and place it on the table at normal temperature, what will happen to the ice? It, it will start to melt. So that is reversible. When you place it again inside the refrigerator or the freezer, then it will turn into solid form. So that's reversible. So pwedeng ibalik sa dati. Pero may mga bagay na hindi pwedeng ibalik. Okay, except for this cases. So there are evidences of chemical reaction. Or how can we tell that there is chemical reaction? I've been mentioning that before, that there are some indicators or proof or evidences that there is chemical reaction when, first, when there is change in color. Just like this example, you have clear water, and when you add some substance to it, it changes its color. So therefore, there is a chemical change. Okay? Or that one, when you mix different substance and there is colors that will appear, then that is chemical reaction. If you remember during Christmas or during New Year, firecrackers or the fireworks that we have emits different colors, right? And they are very colorful because they react with one another. So that means there is chemical reaction. Second, when there is evolution of gas or when there is formation of bubbles. Now, if you remember the experiment that I show you with the presence of the catalyst, what do you notice? When I place the yeast in the container with hydrogen peroxide, it starts to bubble or bubble is formed. So that is an indicator that gas is forming. Okay, That is an example. I remember when you use agua oxinada and you place it in a particular wound, di ba makikita mo, bubula yan. There are bubbles. So that is an indicator that there is a chemical reaction. What else? If you are using, when you clean your bathroom, sa mga CR, pag nilagyan mo ng, ano ba yung nilalagay? Yung mga cleaning materials, pag nilagay mo doon, di ba bumubula siya. So that is an indicator that there is chemical reaction. Or even when you are washing, pag gumamit ka yung yung violet na pang-colored na zone rocks, pag nilagay mo yan, di ba, automatic magbubula-bula siya. Those are examples of chemical reaction. That one. Okay, another one is when there is absorption of heat or when there is cooling of particular substance, or if there is formation of spark, or if there is flame involved. Those are indicators that there is chemical reaction. Okay, whether it is endothermic or exothermic. When I say endothermic, the surrounding is getting cooler, while for exothermic, the surrounding getting warm. So, as you can see, endothermic, when the temperature is less than 0. Exothermic, when heat or the temperature is greater than 0. So, those are indicators also. And then, when there is formation of precipitate, when I say precipitate, these are insoluble solid. Or, for example, when you prepare juice, for example, using Tetra Pak, and then you mix it with the water in the container, and not all of them are dissolved, right? Those are example of precipitate. Another example of precipitate, when you cook rice, di ba, you have to clean first the water, and then the first cleaning of the rice, say for example, if you set it aside, after how many hours, you will see that there will be precipitate that will be subsiding inside or at the bottom of the container. Okay. This is an example of precipitate. As you can see, you have there the solution and you place some substance, and those that are not dissolved can be considered as suspension, while those undissolved substances can be called as precipitate, that they usually settle at the bottom of the container. Say, for example, this one. They are insoluble. Maybe this is a mixture of oil and water, so they don't mix. Next is a reversible reaction. When I say reversible reaction, in a closed system, reactants are added to it or taken away, but it will achieve its equilibrium. In other words, reaction goes the same rate in both directions. So we have reversible reactions. You have here the diagram, A plus B. Then the symbol is reversible. Then the product you have C plus D. Whether it is endothermic reaction, when the temperature is increased, more product is produced. But when decreasing the temperature, less product is produced. Or when it is exothermic reaction, when there is an increase of temperature, less product is produced. But if there is decrease in temperature, more product is produced. So as you can see, it is a reverse of endothermic and exothermic. Okay, here in exothermic, less product, increased temperature, less product, decreased temperature, more product. But here in endothermic, increasing the temperature, more product is produced. Decreasing the temperature, less product is produced. That is reversible. Okay, example, here. This is a best example. Is this reversible or irreversible? When I say reversible, pwede mong ibalik. Pwedeng ibalik ang dati. Okay. But, if it is irreversible, you could not return it to its original formation. Okay, just like when you cook egg, for example, can you return it to its original formation? Magiging egg ba siya katulad nung hindi mo pa siya niluto? Of course not. So this is an example of irreversible change. So you could not return it to its original position or its original component. Another example is the ice drop, for example. Do you think this is reversible or irreversible? Okay, very good. Exactly, this is reversible. When you take out of this ice drop in the freezer, it will melt. But if you are going to return it to the freezer, then it will return to the solid formation. So that is reversible. So ibig sabihin, pwede siyang bumalik sa pagiging solid and then to liquid state. So that is reversible. Another example of irreversible changes, for example, you have here a fuel and oxygen, then it will create fire or flame. So when there's fire, of course, it will produce ashes. Say, for example, if there is fire in your community, there will be smoke production that would create heat. Can you reverse the reaction? Pwede mo ba siyang ibalik sa dati? Na naging flame siya, babalik mo siya sa fuel, to oxygen, or ibabalik mo yung ash to kung ano man yung nasunog na bagay? Can you return it? Of course not. So this is an example of irreversible. In a reaction such as burning that causes two substances to form is called a chemical change, and these changes are irreversible. Look at this example. Do you think this equation is reversible? You have two molecules of hydrogen and two molecules of hydrogen and oxygen gas that would yield two molecules of water. So all of them are in gaseous state. Do you agree that water is in gaseous state? No, it's not. Water is in liquid state, so that should be L. I'm asking if this is irreversible or reversible. Okay, let's take a look. In this equation, we have here the reactants or the substrate, and this is the product. Now, in this reaction, that is the coefficient, and this is the chemical formula. And what else present here? Okay, the subscript. That would indicate how many molecules are present, or how many molecules of oxygen present or hydrogen present. Now, I'm asking if it is reversible or irreversible. For example, you have water. Hydrogen and oxygen are both gaseous state. If you have water, When you apply heat, when you boil the water, what do you notice? It will be boiling, and when it boils, it will start to evaporate and gas will escape. So, pag tinagalan mo yan pag-boil, what do you notice? May tubig pa ba na matitira? Di ba wala na po? So, ibig sabihin, the gaseous state or the water that evaporates would indicate that the gas escaped from the liquid state of water, and it is already in the formation of gases. Tanong, can we still have this hydrogen and oxygen back? Yes, when they react with hydrogen and gas in the atmosphere, it will form into water. That's why we have precipitations and we have rain. That is how the gaseous state turns into liquid state. So this example is reversible. Now, what are the different types of chemical reaction? One of the type of a chemical reaction is the synthesis reaction. What do we mean by synthesis reaction? It is a reaction when A plus B yield into AB. So that, or it simply means that there is, sometimes they call this one as combination reaction. Synthesis or combination reaction. Example, calcium plus sulfur, it will yield into calcium sulfide. Okay, remember the tutorial that I gave you on naming some chemicals? When there is, you have to identify whether it is anion or cation. Name the anion first, cation first, and then the anion change it to IDE. So in this example, calcium is a cation, while sulfur is an ion. That's why we name calcium first and then sulfide next. So you have to change sulfur into sulfide, or change the last three letters into IDE. I hope that's clear. This is synthesis reaction. Okay, for example, we have A plus B yield into AB. First example, you have two molecules of magnesium plus oxygen gas yield into two molecules of magnesium oxide. Now, if you notice, you have already a coefficient of 2. So that means we balanced already the equation. So to check whether it is balanced, so how many magnesium do we have? So that's simply multiply 2 times 1, you have 2. Here also 2 times 1 is 2. Oxygen is 2, 2 times 1 is 2. So therefore it is balanced. Next example, you have nitrogen gas and 3 molecules of hydrogen gas. So it will yield into 2 molecules of ammonia. So NH3 is ammonia, and ammonia is in gaseous state. Okay. Next, you have sulfur trioxide. Why trioxide? Because all of these are non-metals. So sulfur is non-metal, oxygen is non-metal. So you will remain their respective names, but of course you have to consider the using tri, mono, hexa, and or the prefixes that I told you before. And plus water, it will yield into sulfuric acid. Now, if you see hydrogen at the when you see hydrogen in front of a solution, that means it is acid. Pag merong H. Okay? So that is sulfuric acid. Okay? Another one is the decomposition reaction. That's the second type of reaction. Okay, the first one is combination or synthesis. Okay, the second one is decomposition reaction. When we talk about decomposition, you have AB, it will yield into A plus B. So we have here AB, then it will just split into two substances as A plus B. For example, you have water. So water is already a compound. Can we decompose it into hydrogen and oxygen? Yes, you can. So what would be the product? It would be oxygen gas and hydrogen gas. So AB yield into A plus B. Um, Two molecules of copper chloride, and copper chloride is already in solid form. So it will yield into 2 copper plus chlorine gas. So you have here the A and B yield into A plus B. Another example, yeah, I have mentioned this already. You have water. So you will yield into 2 molecules of hydrogen gas and oxygen gas. Okay, next example, or the third type of chemical reaction is a single replacement. So single replacement. So isa lang ang papalitan. Okay, example, you have A plus BC, it will yield into B plus AC. So, ibig sabihin, yung B matatransfer sa posisyon ni A at si A mapapalit doon sa posisyon ni B. That is single replacement. Kaya hindi pwedeng magpalit ng sabay-sabay. Isa-isa lang. Okay. Okay. You have here the diagram or the equation. A plus BC yield into B plus AC, or AB plus C yield into AC plus B. So it depends on what type of chemical is given, provided that only one is being replaced. So that is single replacement. So isa-isa lang. Hindi pwedeng dala-dalawa. So example, you have magnesium plus copper sulfate. It will yield into magnesium sulfate plus copper. I hope you are already familiar in naming some chemicals, chemical formula. Another example, you have magnesium plus hydrochloric acid. It will yield into magnesium chloride plus hydrogen gas. Another example, you have two molecules of sodium bromide plus chlorine gas. It will yield into nitrogen trichloride and bromine gas. So you will find out why we use trichloride. Okay, based on the N is positive, N is negative 3, and chlorine is negative 1. So, saan po nakukuha yung 3? Galing po sa N. Kaya, we name that as nitrogen trichloride. Why? Because all of them are non-metals. Fourth is the double replacement. When you talk about double replacement, two position is being replaced or they changes with its position. You have AB plus CD yield into AD plus CB. So if you notice, A paired with D and C paired with B. For example, you have barium chloride plus magnesium sulfate. What do you think will pair? Given the equation above? Okay, very good. That's barium sulfate. Barium sulfate plus the other compound is magnesium chloride. Very good. So in short, this is how we identify their chemical formula. If you notice, we consider the positive charge and the negative charge. Okay, barium is a cation of positive 2, while magnesium is a cation of positive 2. Chlorine is anion negative 1, and SO4 is um, negative 2. This is, or we call this one as polyatomic ions. So that's why in our formula here, barium SO4 do not have anymore the subscript of 2. Why? Because barium is positive 2, SO4 is negative 2, so they can cancel out. So magnesium remain positive 2 and chlorine is negative 1. Okay, that's why in our formula you have magnesium and chlorine subscript of 2. That comes from magnesium positive 2. Here is another example. You have silver nitrate plus sodium chloride. It will yield into silver chloride and sodium nitrate. Okay, next you have barium chloride, magnesium sulfate. It will yield into barium sulfate and magnesium chloride. I think that's the example that I gave. Okay, anyway. Okay, third example, you have silver nitrate plus potassium chromate. It will yield into silver chromate and potassium nitrate. So what changes only is the D and D and D and B. So they changes or they change position. Now the fifth one is combustion. Okay, when I talk about combustion, this is a reaction or a compound react with oxygen to form oxide and produce heat. Most of the time, this is hydrocarbons. So hydrocarbons combust with oxygen to produce carbon dioxide and water. So always remember this. When there is hydrocarbon, their main product are carbon dioxide and water. So for example, you have CH is hydrocarbon, which contains carbon and hydrogen. So the X and Y represent kung ilan ang nakalagay dyan, kung C6, H6, or C6, H12. So depende kung ano yung subscript. But always their product is water plus carbon dioxide. Just like this one, CH4 plus oxygen gas. Okay, CH4 is methane. Okay, methane plus oxygen gas. The product is water plus carbon dioxide. Kahit anong ilagay mo dyan na hydrocarbon, always their product is water and carbon dioxide. You have C5H12 plus oxygen gas. It will yield into water and carbon dioxide. But always remember that it always reacts, or one of the reactants is oxygen. So what are the requirements for a combustion reaction to occur? Of course, first, there will be fuel. Then oxygen would be present. And because they are present, it will produce heat. That is the chain of the chemical reaction when there is combustion. Now, what about for neutralization reaction? From the word neutral, you have to neutralize the reaction. So the reaction of an acid with a base to form salt and water. So in this case, their product is always salt and water. Okay, acid is a compound that dissolves in water to produce hydrogen ions. Yes, that's true. And base also dissolves in water to produce hydroxide ions. It is usually a soluble metal hydroxide. So remember the different components: salt, water, acid, and base. for neutralization reaction, we mentioned that there should be the presence of acid plus base yield into salt plus water. So for example, you have hydrochloric acid plus sodium hydroxide. It will yield into sodium chloride plus water. And sodium chloride is salt. Okay, next example, you have phosphoric acid plus potassium hydroxide. It will yield into potassium phosphate and 3 molecules of water. Another example, potassium phosphate is a salt, another type of salt. Sulfuric acid plus sodium hydroxide, it will yield into sodium sulfate plus water. Another example, you have 3 molecules of chloric acid plus aluminum hydroxide. It will yield into aluminum chlorate plus water. In next example, you have 3 molecules of potassium chloride plus aluminum hydroxide. It will yield into aluminum chloride plus water. And our last example is sulfuric acid plus uh, iron hydroxide. It will yield into iron sulfate plus water. So this is an example of neutralization reaction. So you have the acid and the base. It will give salt and water as their product. Next is the precipitation reaction. From the word precipitate, there will be um, compounds or there will be precipitate that will be suspended at the bottom of your container. So since precipitate are insoluble solid that separates from the solution. Okay, example here in our compound lead iodide. So what would be our chemical or molecular equation? You have lead nitrate is an aqueous solution plus 2 molecules of sodium iodide, which is also in aqueous solution. It will yield into lead iodide, which will serve as the precipitate, and 2 molecules of sodium nitrate. So when we talk or when we check why there will be precipitate, if we look at into the ionic equation, the body equation is already balanced, and then we can cancel out 2NO3 and 2NO3. You have 2Na or 2 molecules of sodium and 2 molecules of sodium. So what will be the net ionic equation? It will be lead plus iodine. It will give into or it will yield into lead iodide. So this will be the net equation. Now what will happen to sodium and nitrate? This will be an spectator ion. When I say spectator ions, these are the ions or the type of compounds that would most likely dissolve or combine with our solution. But the lead iodide will always be our precipitate. Now here are some exercises that I'm going to give you. I want you to indicate what type of reaction taking place. Okay, first, you have sodium bromide and phosphoric acid. So what the product is sodium phosphate plus hydrogen bromide. So you can answer this. This will serve as your assignment. You check what type of chemical reaction is given or presented in this type of reaction. Whether it is synthesis, combination, decomposition, single replacement, double replacement, or could it be a combustion, a precipitate, or a neutralization reaction. So third, magnesium plus iron oxide, it will yield into iron plus magnesium oxide. Okay, 4, then you have CH2, C2H4 plus oxygen gas. It will yield into carbon dioxide plus water. Okay, the number 5 is lead sulfate. It will yield into lead sulfide plus oxygen gas. Then number 6, 7, 8, 9, and 10. I hope you can now identify what type of chemical reaction is presented in this set of examples. I want you to try to answer it first, and then you can check it using the internet, or you can go back to the equations that we have, especially on the different types of chemical reactions. I hope this will help you, or it will help you in our next lessons. You know already what are the different types of chemical reaction, and more or less you know how to balance the equation. But I'll be giving you another separate tutorial or review lessons on the chemical balancing of chemical equations. Once again, thank you for listening. Okay, this is Mrs. Moreno. I hope this will help you a lot in refreshing your knowledge about chemical reactions, so that you will be equipped already and ready to our next lessons next week. Okay, hope to see you guys. Thank you.